Hello, we are Arrowhead Robotics, Team 3773. I am Blakely Rains, the team captain.
I'm Caden Osterman, Head of Fabrication and Design.
I am Sean Peacock, and I am the lead software engineer.
Today we'll be discussing what our program is and what it aspires to be. Our team, Arrowhead Robotics, is a member of the First Robotics Competition, or FRC for short. First Robotics is an organization that strives to unite the best aspects of science and technology by annually challenging student-led teams like ours to fund, design, and build industrial-sized robots. Not only is this fun and exhilarating, it is an invaluable opportunity to learn real-world engineering. Like many things in 2021, FRC had to adapt its traditional approach to a COVID-wary one. To make the challenge feasible, teams were given a modified version of the 2020 Infinite Recharge Challenge. Among the options FRC offered, we accepted 3 challenges: Hyperdrive, Intercellular Accuracy, and Powerport. I'll briefly explain each one of these to contextualize our robot and design process. In the Hyperdrive Challenge, our robot navigated around obstacles to complete a set course as quickly as possible. In the Interstellar Accuracy Challenge, our robot shot balls at a target to score either 2 or 3 points, depending on whether they entered through the inner or outer port of the target. Lastly, the Powerport Challenge consists of shooting and scoring the maximum number of balls in the target. Once assigned our challenge, Arrowhead Robotics laid out its goals. We sought to, among other things, almost completely redesign our shooting system, improve our accuracy by automating certain tasks, and automate our conveyor and indexing of balls. Combined, our improvements would make for a faster, more precise robot. To accomplish our goals, we also revised our building philosophy to avoid paralysis by analysis, and to build, test, and improve effectively.
On the design side of things, we had to figure out what we wanted to do. We then took this and made a rough design on a whiteboard. We took this whiteboard design and made a prototype out of it. We tested that and see what worked and what didn't. We then made a more detailed design on CADing software. And then we saw things such as constraints for building to see what was interacting with one another. We then took this and we made a model out of it that we could put on the robot. We then tested this a few times to see what didn't work that we can't see on the CADing software, such as vibration tests. We continued this process until we had a finished product.
Our targeting system is made up from a bow sight, which is used to determine the position and relative distance from the robot to the goal, and the angle needed to shoot the ball. The information we receive from the sight would be used to set one of our preset angles, or we would make slight adjustments and fine-tune our angle.
The software side of the targeting system made aiming more efficient. There is an encoder on the motor that actuates the position of the propulsion system. This encoder relays the relative angle of the system and allows for an exact preset angle to be reached once a button is pressed on our joystick. In addition to that, the user may manually fine-tune the angle up or down.
Our conveyor is made up of a belt-driven mechanism triggered by an IR sensor. 4 wheels rotate about an axis to intake the ball. Once obtained, the ball triggers an IR sensor which runs the belt that leads the ball to the power cell propulsion system.
The software side of the intake system is largely regulated by IR sensors. When a ball is taken in, it briefly breaks the IR sensor beam, triggering the conveyor belt to briefly run. This continues for 3 balls, all of which can comfortably fit in the robot thanks to automated indexing. Here's an example of our finished product. Here is our FRC robot in the Powerport Challenge. At every point in helping this robot come to fruition, lessons were learned. Measure twice, cut once. Caliper is in fact more precise than mine. Teamwork means everyone working together. These lessons and of course our robot are rewarding, but they come at a cost. A typical entry fee for an FRC team like ours is $5,000. Essential parts like the rolling wheel, the brain of our robot, and a standard laptop runs in the hundreds. It is thanks to sponsors like you that Arrowhead Robotics is able to pursue its dreams and inspire the future. Thank you for your time. Thank you.